Hi, welcome to Our Math. Today I'm doing a series of videos on systems of equations and solving them algebraically. Okay, so in this one our x's are lined up, our y's are lined up, the equal signs are lined up, the answers are lined up, so this looks like a perfect time to use elimination. So we will eliminate our x's because 5 goes into 10 twice. I'm not going to multiply by 2, I'm going to multiply by -2 because I always want to be able to add down. And if I just multiply by 2 and I ask myself to subtract, I will definitely subtract the first term. I may even subtract the second, but by the third, your brain is going to want to be adding down because that's what we're used to doing. Multiplying through by -2 solves that. So the top equation becomes -10x minus 6y equals 24. The bottom equation is 10x plus 6y equaling 10. And what happens is our variables all fall out. When this happens and you end up with a statement that's false, that translates to no solution. No solution, you can either write no solution or you can write parallel lines. To me, the words parallel lines make more sense. I'm asking you to find out where this line and this line intersect. Well, they don't. They're parallel. There is no solution. But both of the two answers are perfectly acceptable. Sometimes you get empty set when you are looking for the set of answers. It's the empty set because there are no solutions. All of these are equivalent. Okay, so for my next problem, this to me looks a lot like substitution, but before I can substitute, I want to get rid of these decimals very, very badly, at least most of them, if not all of them. I'm going to multiply through everything by 10. I'm going to multiply 10 here, I'm going to multiply by 10 here, I'm going to multiply by 10 here, and I'm going to multiply by 10 here. Then I get 6m minus 2n equals 9, and 3m equals 4.5 minus n. Okay, that looks a lot better. And it also looks like if I add this n over, I have 3m plus n equals 4.5. And because this is a -2 and this is a +1, I'm changing my mind. I think elimination would be better. So if I multiply this through by 2, I get 6m plus 2n equals 9. And then I'm going to bring this down, my first equation, which was 6m minus 2n equals 9. And when I add down, I get 12m equals 18. I'm going to divide by 12, and I'm going to get that m is equal to 1.5. Hold on! Fractions! When the equation is given as a decimal, you should leave your answer as a decimal. This tells you that everything is estimated, rounded, error is already implied, and so a fraction is not appropriate. It is not appropriate to go from a decimal to a fraction. Just that does not work. We can go from fractions to decimal, that means precision to estimate, but you can't go from estimation to precision. Okay, I'm going to come back up to my original problems to figure out and to make sure in all of this manipulation I didn't do anything wrong. Okay, so 0.6 times 1.5 minus 0.2n equals 0.9. Okay, so 0.9 minus 0.2n equals 0.9. We subtract the 0.9. Okay, so here's the next mistake I often see students doing. They freak out at 0. 0 is a beautiful answer because it is. N equals 0. It's the easiest to check. If n equals 0, well, is 3 times 0.3 times 1.5, 4.5, 0.45? It is. It's easy to check. It is so easy because we don't even write down the 0 term because it could just get in the way. It checks out. We have our answer. So the answer is going to be 1.5 comma 0. It just means it crosses an axis. It's allowed to be 0. Don't think zeros are anything but good. You only get parallel if you lose your variables. We didn't lose our variables. We didn't lose our variables. We just have a 0. All right, I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.